Welcome to Science for Sleepy, the quiet corner of the internet where you can close your eyes, pull the blanket a little tighter around your shoulders, and still drift into the vastest mysteries of the universe. Tonight, we're stepping into one of the strangest, most unsettling, and yet oddly comforting ideas ever suggested. What if the universe itself has no beginning and no end? Not a single spark that started it all. Not a future moment where everything stops, just forever stretching in both directions, like a road without a start or finish line. That thought alone is almost too big to hold in your mind. If the universe has always been here, it means that every moment you can imagine is only one dot on a line that has no edges. It means there was never a time when nothing existed. No silence before the first sound, no darkness before the first light. And it also means there might never be a last breath of the cosmos, no final fading into nothingness. The universe would simply be, with no origin story and no epilogue. Now, before we drift too far into infinity, can I ask you a favor? If you're listening to this right now, could you go down into the comments and gently tell us where in the world you're watching from and what time it is there? It's always fascinating to imagine someone wide awake in the middle of the day while another listener is already deep under the covers, letting their mind wander before sleep. And while you're down there, would you mind subscribing to Science for Sleepy? After all, if the universe really has no beginning and no end, then subscribing to this channel is basically your way of joining something eternal. And don't worry, we upload a new video every single day, so no matter when you come back, tomorrow, there will always be something waiting for you. Now, let's return to that big, strange idea. For most of human history, the idea that the universe might be eternal without beginning and without end wasn't shocking at all. In fact, it was comforting. Early people looked at the stars and saw the same sky their grandparents had seen. The moon rose and set, the sun traced its path, the seasons cycled, and everything repeated. It was easy to believe that the universe was just like the circle of the year, endless, repeating, never starting, never stopping. But here's where things get unsettling. If the universe really has no beginning, then there was no first moment. That means all of history, the rise of cities, the building of pyramids, the discoveries of scientists was not just a story told from page one. It was instead a chapter buried deep inside a book, with no first page and no last page. Imagine opening a novel in the middle and realizing that the story stretches back infinitely before the chapter you're reading and continues endlessly after. That is what an eternal universe implies. When you think about it this way, it raises some very simple but very strange questions. If there was no beginning, why does anything exist at all? If time has been flowing forever, why do we find ourselves at this moment and not some infinitely far-off past or future? And if the cosmos has existed forever, shouldn't it have already burned itself out into cold emptiness? These aren't just abstract questions for philosophers sitting under olive trees 2,000 years ago. They're questions that have kept astronomers awake at night in the last few centuries, looking up at the sky and trying to measure the stars. And what's surprising is that the most basic, boring details like how bright the night sky is actually hold some of the deepest clues. But before we get to that, let's stay for a moment with this ancient idea of eternity. Imagine yourself lying outside on a quiet evening thousands of years ago, with no electricity, no noise, only stars overhead. To those who lived then, the sky was a fixed pattern. The stars didn't fade away. The moon never skipped a cycle. To believe the universe had always been there was simply common sense. It felt solid, dependable, unshakable. The heavens didn't change in a human lifetime, so why would they ever have had a first moment? The philosopher Aristotle, for example, believed the universe was eternal. To him, time had no starting gun. Motion, matter, and the heavens had always existed and always would. He wasn't alone. In India, ancient thinkers described time as a wheel, endlessly turning, with no true beginning. Early Babylonian and Egyptian skywatchers, too, saw the heavens as a repeating stage where the same cosmic patterns played again and again. This is the first striking thing about the question of beginnings. For much of history, the natural instinct was not to imagine a sudden spark of creation, but rather to assume no such spark was necessary. Eternity was easier to picture than nothingness. After all, how could something come from nothing? That simple question has haunted every thinker who has ever wrestled with the idea of a universe that started. And that brings us to the tension that lingers even now. Is it more natural to think that the universe has always been here, or that it popped into existence at some point in the distant past? Neither answer sits comfortably. If it always existed, you have to accept infinity in a very literal sense. But if it had a beginning, you're faced with the unsettling idea that before the beginning, there was not even time. This question is not just a curiosity, it's at the heart of how humans tell stories about the world. You may have noticed how every culture, every religion, every philosophy tries to explain origins. Where did the world come from? Why are we here? Whether the answer is a god, or a cosmic egg, or cycles of rebirth, it always starts with some explanation of the first moment. But what if there was no first moment at all? As you lie there listening, try to imagine eternity stretched backward. Picture time as a line on a piece of paper, and instead of an edge, imagine arrows pointing in both directions, stretching endlessly. Somewhere on that line, your life appears as a small dot. Your grandparents and great-grandparents are dots before you. Your descendants will be dots after you. But the line itself never stops. It's unsettling, because our lives are defined by beginnings and endings. You are born, you will someday die. So how can the universe itself refuse to play by those same rules? It's a question that ancient thinkers left hanging in the air, and it's one that modern science is still trying to answer. In the sections to come, we'll explore how people across centuries tried to wrestle with this problem, sometimes clinging to eternity, sometimes clinging to a beginning. But for now, let this question sit with you as you drift deeper into thought. If the universe has no beginning and no end, what does that make your life? A temporary ripple on an infinite sea, or part of something that never needed to start in the first place? If you could travel back thousands of years and lie down under the same sky our ancestors stared at, you might be surprised by how familiar it feels. The stars would still appear as glittering points, the moon would still rise and fall, the constellations would still crawl across the night like quiet animals etched into the dark. What you would not see is change. There would be no sign that the universe had ever started, and certainly no hint that it might one day end. To early people, eternity was not a puzzle. It was simply the backdrop of existence. In ancient Greece, philosophers tried to make sense of this eternal stage. Aristotle, perhaps the most famous, believed that time itself had no beginning. To him, asking when time began was like asking what lies north of the North Pole. The question made no sense. Time was the measure of motion, and motion had always existed. The sun had always risen and set. The heavens had always turned. In his view, the universe did not need a starting point because it was, by its very nature, eternal. It sounds abstract, but think of it this way. If every day you have ever known has had a yesterday before it, why would you assume there was a first yesterday? Aristotle extended that simple idea into the cosmos. Just as a circle has no start or end, so too did he see the universe. It was an elegant explanation, even if it left some people unsatisfied. Not far away in the ancient Middle East, thinkers were also wrestling with eternity. The Babylonians were meticulous sky watchers. They tracked the movements of planets and stars, sometimes for centuries, recording everything on clay tablets. What they saw was repetition. Venus rising and falling in predictable cycles, eclipses repeating after long but exact intervals, constellations returning in order. This steady repetition convinced many that the cosmos itself was a kind of eternal machine. To them, the universe was not a story with a beginning, but a cycle repeating itself endlessly. The Egyptians, too, saw the universe through cycles. The annual flooding of the Nile, which made their civilization possible, was as dependable as the rising sun. To them, the cycle of water, planting, harvest, and flood was a reflection of eternity itself. Even their gods were woven into these endless loops. Creation, destruction, and rebirth repeated over and over without a clear first cause. But perhaps the most striking ancient vision of an eternal universe comes from India. Hindu philosophy described time as vast cycles called kalpas, so long that even trying to measure them with ordinary numbers seems absurd. In these cycles, universes were born, lived, and then dissolved, only to begin again. There was no final creation, no last ending, only an infinite wheel turning endlessly. To give you a sense of scale, some texts describe a single cycle as lasting billions of human years. And these were not one-time events, but patterns repeated forever. Imagine being told that your life, with all its worries and joys, exists inside just one breath of a cosmic being, and that countless breaths came before and will come after. It's overwhelming, but it also offers a strange comfort. If the universe has no beginning, then your life is not hanging over a void. It's resting on a wheel that never stops turning. These ideas were not identical, of course. Aristotle's eternal cosmos was not the same as India's cyclical universe. The Babylonian star charts were different again from Egyptian myths, but all of them shared one assumption. The universe was not born at a particular moment. It had always been there. It's easy to understand why this view was so natural. When you look at the sky, you don't see evidence of a beginning. The stars don't appear to have been lit one day. They simply are. The human mind finds it much easier to imagine continuation than origin. You know how to picture tomorrow, because it follows from today. But how do you picture a before the first day? For early thinkers, that was a meaningless question. And yet, even in these early times, not everyone was content with eternity. Some traditions hinted at creation stories, at beginnings sparked by gods or by chaos resolving into order. In Mesopotamian myth, the universe emerged from a battle of primordial waters. In Egyptian myth, a mound of earth rose from infinite floodwaters to start the world. In the Hebrew tradition, a divine command called the cosmos into being. These stories did not agree with Aristotle or with Indian cycles. They suggested a first moment, even if they explained it in poetic rather than scientific terms. This tension between eternity and creation runs like a thread through all human history. On the one hand, eternity feels simple, no need to explain how something came from nothing. On the other, beginnings feel natural after all. Everything in human experience has a start. You are born, a fire is lit, a story begins. To imagine a universe with no such beginning stretches the mind almost painfully. To bring this closer to your own life, imagine sitting by a fire. You know that the fire was lit at some point. Before it, there were only unlit logs. It would feel absurd to claim that the fire had always been burning. But when you look up at the stars, they do not flicker like logs. They do not reveal their start. They shine as though they have always shone. That contrast between the fires of earth and the fires of heaven may be why humans have never stopped arguing about whether the universe had a first spark. The Greek philosopher Lucretius, writing in ancient Rome, offered another angle. He believed the universe must have had a beginning not because he could prove it, but because if it had always existed, human history would be infinitely long. And if it were infinitely long, why had humans not built more, discovered more, achieved more? For him, the absence of infinite monuments was proof that time itself was not infinite, a surprisingly practical argument against eternity. Meanwhile, in India, the sheer vastness of cycles made the question of beginnings feel less urgent. If a single cosmic cycle lasted billions of years, then from a human perspective, it might as well be eternal. No single lifetime could ever see the difference. Eternity was not something to be proven or disproven. It was simply the context in which everything existed. As you think about these early visions, notice how each one reflects the daily lives of the people who imagined them. Farmers by the Nile saw cycles of flood and harvest, so they imagined cycles of the cosmos. Babylonian sky watchers saw predictable patterns in the heavens, so they imagined an eternal cosmic order. Indian philosophers lived in a world where time itself was stretched into unimaginable scales, so they imagined cosmic wheels without beginning. Greek philosophers, trained to argue and analyze, turned eternity into a logical necessity. In all of these stories, the universe is not fragile. It is not fleeting. It does not appear suddenly from nothing, nor vanish into emptiness. It simply continues, like the turning of the stars above your bed tonight. And yet, even here, thousands of years ago, the question lingers quietly in the background. If the universe has no beginning, then what exactly does time mean? Is it just the endless ticking of a cosmic clock? Or could there be something deeper, something stranger, hiding beneath eternity itself? If you close your eyes for a moment and imagine yourself thousands of years ago, sitting by a fire with nothing but the night sky above, you might begin to understand why stories of beginnings became so important. The fire you sit beside had a clear start. Someone gathered wood, struck sparks, and coaxed a flame into life. The village around you had a start. Someone built the first hut. Someone dug the first well. Even your own life had a start, in the quiet and unrecorded moment when you first cried. So why would the universe be different? This is where religion and myth stepped in. Across cultures, humans began telling stories not only of gods and heroes, but of creation itself, the very first moment, the start of all starts. These stories were rarely quiet speculations. They were bold, vivid, filled with drama and meaning, and yet, beneath the color and poetry, they often wrestled with the same quiet puzzle. Was the universe born in a single moment, or has it always been here? In Mesopotamia, one of the earliest civilizations, a myth called the Enuma Elish describes creation as a struggle. The world begins not from nothing, but from a conflict between watery chaos and emerging order. Out of the clash of primordial beings, the sky and the earth are carved, like a craftsman shaping clay. In this story, the universe clearly has a beginning, but it is not a peaceful one. It is born in violence, in division, in the taming of chaos. And yet, the waters from which creation is carved feel eternal. The myth does not truly erase eternity, it only rearranges it into a starting point. In Egypt, creation myths offered multiple variations. In one, the world begins when a mound of earth rises from endless waters. On that mound stands a god who calls forth the first light. In another, creation begins with a cosmic egg cracked open to release the world. The Egyptians lived surrounded by cycles, the flooding Nile, the daily journey of the sun god Ra across the sky. Their creation myths often mirrored those cycles, suggesting not just one beginning but beginnings that could repeat, echoing eternity in the form of ritual rebirths. Move further east to India, and the stories take on an even larger scale. Hindu cosmology speaks of universes created and destroyed in infinite succession. Gods like Brahma may create the world, but not once over and over, across cycles so vast that they dwarf human imagination. Each cycle lasts billions of human years, after which everything dissolves, only to begin again. In these myths, beginnings exist, but they are not unique. They are points on a wheel that turns forever. Here, the tension between creation and eternity dissolves. Both are true. The universe has beginnings, but those beginnings themselves are eternal in their repetition. In ancient Greece, myth and philosophy sometimes overlapped. Before Aristotle's logical eternity, there were the stories of Hesiod, who wrote of chaos as the first thing to exist. From chaos came Gaia, the earth, and then the gods. This was not eternity, but a beginning, a first unfolding, and yet, even chaos feels eternal, like a formless background that had always been there, waiting to produce the world. The Hebrew tradition, which later became foundational to Christianity and Islam, took a different stance. In the book of Genesis, creation is described as a deliberate act of God. In the beginning, the text begins, clearly pointing to a first moment. Time itself is born when light is separated from darkness, when day is separated from night. Unlike Hindu cycles or Egyptian rebirths, this is a linear creation, one beginning, moving forward into history, with an implied end somewhere in the future. This was a profound shift, one that shaped not only religious thought, but later scientific debates. You can almost hear the quiet argument across cultures. Some said the universe had always been, others said it was born once. Some said it was born many times, over cycles so long they felt infinite, and each story reflected the daily life of its people. Farmers in Egypt saw rebirth every year in the Nile. Philosophers in Greece valued logical eternity. Poets in Mesopotamia saw creation as a struggle. Prophets in Israel told of a divine word that sparked time itself. For you, lying there now, perhaps half asleep, the contrast might feel familiar. Your life has beginnings and endings, school years, jobs, friendships, even single evenings that start with daylight and end in sleep. But the world around you, the stars above your ceiling, seem unchanged. The pull between beginnings and eternity is not just ancient, it is personal. You live inside it every day. What's interesting is how often these myths wove both ideas together. Even when they spoke of a beginning, they often described it as emerging from something eternal: chaos, waters, darkness, a void. Eternity remained, but it was hidden just beneath the surface of creation. In a way, these myths seem to say, yes, there was a first day, but behind that day stretched a timeless backdrop. The beginning was only a doorway into a larger forever. This dual vision creation, emerging from eternity, would echo into philosophy and eventually into science. When modern thinkers debated whether the universe had a beginning, they often echoed these ancient stories without even realizing it. The same discomfort lingered. Can you really have something come from nothing? And if not, does eternity sit quietly behind every beginning we imagine? Let's pause here and bring this down to something simple. Imagine baking a loaf of bread. You know when it begins when you knead the dough, when you put it in the oven. Before that, there was no bread, only ingredients. That's a beginning. Now compare that to a river flowing past you. You see it arrive from one direction and vanish into another, but you cannot point to its start or end. It simply flows. Myths of creation often describe the universe like the bread, with a clear moment of rising. Myths of eternity describe it like the river, endlessly flowing. And some myths, especially in India, combine the two. The bread is baked, eaten, dissolved, and baked again, forever. All of this might feel distant, but notice how these stories shaped not only cultures, but the way people thought about life itself. If you believe in a universe with one beginning, you might also believe in one human life with one clear end. If you believe in cycles, you might see your life as one turn of the wheel, with others to follow. If you believe in eternity, you might see your own existence as a small but permanent ripple in a timeless ocean. And so the question grows larger. These are not just tales of gods and stars. They are reflections of human attempts to anchor meaning in a universe that might not give us simple answers. If the universe has no beginning, do we still need stories of creation? If it does have a beginning, what existed before? These are the same questions that later scientists would wrestle with, often without realizing they were walking paths carved long before them by myths told beside fires. Myths, in their own quiet way, kept the tension alive, passing it forward like a torch. As you drift toward the next part of this story, consider this. When you imagine the universe beginning, what picture comes into your mind? Is it an explosion of light, a voice speaking into darkness, a god cracking an egg? Or is it something softer, no beginning at all, just the endless flow of stars that have always been? You might think of the night sky as something serene, even comforting. You lie down, maybe on a soft bed, or maybe outside on a summer evening, and there it is, a vast canvas of stars scattered across the black. But here's something that should trouble you, if you think about it long enough. If the universe really has no beginning and no end, then why is the night sky dark at all? At first, the question sounds almost silly. Of course the night sky is dark, how else could it be? But hold on to the thought for a moment. Imagine an eternal universe, stretching endlessly in all directions, filled with stars. If space goes on forever, and if it has always existed, then no matter where you look, your line of sight should eventually end on the surface of a star. Not just in one direction, but in every direction. Up, down, left, right, the sky should be absolutely filled with starlight, brighter than the sun, leaving no darkness at all. And yet, when you look up, you see mostly black, with only scattered points of light. That is the paradox, first clearly framed in the 19th century by a man named Heinrich Olbers, though others before him had asked similar questions. Why, in an infinite, eternal universe, do we see darkness at all? Let's slow down and really picture it. Imagine walking into a forest that stretches forever in every direction. If the trees are evenly spread, your line of sight in any direction should eventually meet a tree trunk. You shouldn't be able to see gaps. The entire view should be bark and wood. Now replace the trees with stars. If the universe is infinite and eternal, then every bit of sky should be crowded with shining surfaces. The night sky should not be black, it should be blindingly bright, but it isn't. And that single, quiet detail, something so ordinary you take it for granted, holds one of the biggest clues about whether the universe truly has no beginning or end. When Olbers pointed out this puzzle, people offered all kinds of answers. Some said maybe the stars are not bright enough, or maybe dust between them blocks their light. But that doesn't hold up. In an eternal universe, even dust would eventually heat up and glow from all that starlight, making the sky bright. Others suggested maybe stars eventually burn out, leaving gaps. But in an eternal cosmos, new stars would always replace the old. The balance would remain, and the sky would still blaze with endless light. So why doesn't it? Why do we see darkness at all? The simplest explanation is unsettling. Maybe the universe is not eternal after all. Maybe the stars have not existed forever, but only for a limited amount of time. If light takes years to cross space, then there hasn't been enough time for light from all corners of the universe to reach us yet. The darkness might not be an empty void, but rather the space between what light has already arrived and what is still on its way. Think of it like waiting for the sun to rise in the morning. The stars are there, the horizon is there, but the light hasn't reached you yet. For a moment, you sit in darkness not because the world lacks a sun, but because its rays are still traveling toward you. In the same way, the dark night sky may be evidence that the universe had a beginning, not infinitely far in the past, but at some definite point when the first stars began to shine. This is where the universe begins to feel both intimate and strange. Something as simple as the color of the night sky, something you probably haven't questioned since childhood, turns out to whisper a profound truth about existence itself. Darkness isn't just the absence of light. It may be a sign of cosmic youth, a quiet clue that the universe has not been burning forever. But before we rush to that conclusion, let's linger for a moment. Picture yourself standing in that endless forest again. The reason you can still see gaps between the trees is that the forest isn't truly infinite, or at least not infinitely old. It has an edge somewhere, even if it's far beyond your sight. The night sky's darkness suggests the same thing. Maybe the universe does not stretch infinitely back in time. Maybe there was a moment, not so long ago, when the first light was lit. Olbers' paradox didn't solve the mystery outright. It didn't say exactly how or when the universe began, but it cracked open a door that had been closed for millennia. Suddenly, the assumption of an eternal universe didn't seem so obvious anymore. The darkness overhead, something dull and easily ignored, became evidence that eternity might not be real. What's remarkable is how boring this clue is. It's not hidden in equations or buried in ancient texts. It's not locked in a laboratory. It's just the ordinary blackness you see every night. A dull detail, but one with enormous significance. And this is something that happens often in science. The profound hides in plain sight, disguised as something so ordinary you almost don't bother to ask about it. Now, consider how unsettling this must have been for those who believed strongly in an eternal cosmos. For thousands of years, eternity had felt natural. It was simple, it was logical, and yet, the night sky itself was quietly telling another story. If the universe truly has no beginning and no end, the sky should never have been dark. The very fact that you can see blackness between the stars suggests limits, boundaries, beginnings, ends. Of course, not everyone accepted this immediately. Some scientists continued to argue for an eternal universe, offering alternative explanations. Others began to suspect that maybe time itself had a starting point. But the paradox lingered like a quiet itch. If the universe is endless, why do we still live under a ceiling of darkness instead of light? To bring it back to your own experience, think about the next time you're outside at night. Look up at the stars. Notice how much more blackness there is than brightness. In those empty spaces, you may be seeing not just absence, but evidence, a silent argument written across the sky. The darkness itself may be proof that eternity, at least in the way ancient thinkers imagined it, cannot be true. And so, with that one simple observation, the debate about whether the universe has always existed, or once began, took on a new urgency. No longer just a matter of myth or philosophy, it became a matter of evidence. The stars were whispering that eternity might not hold. But here's the open question to leave you with tonight. If the darkness of the sky suggests a beginning, then what exactly began? Was it just the stars, or space itself? And if there truly was a first moment, what could possibly have existed before it? Imagine yourself in the 19th century. The world is quieter, the nights darker, and telescopes are the closest thing anyone has to time machines. Most people still believe the universe has always been here, unchanging and eternal. The stars above your head seem fixed, steady, timeless. But tucked away in observatories, in long nights of tedious measurement, a handful of astronomers are beginning to notice tiny details that don't quite fit. The story of how the universe went from eternal to expanding doesn't start with a single grand discovery. It begins with dull, repetitive work, recording star positions, charting faint smudges of light, comparing notes over decades. Much of it must have felt monotonous. Yet hidden inside those ordinary numbers were hints that the universe might not be sitting still. In the early 19th century, a German astronomer named William Herschel pointed his telescope to the sky and began counting stars. He wasn't chasing beauty, he was building maps. Night after night, he swept the heavens, tallying what he saw. To most, this work would seem boring, almost mechanical. But Herschel noticed something. Stars were not evenly scattered. There were clusters, patterns, concentrations. The universe was not a smooth, eternal field. It had structure. At the same time, faint patches of light called nebulae began attracting attention. Some looked like gas clouds, others like distant whirlpools. Nobody was quite sure what they were. To some, they were proof of creation happening continuously, new stars forming out of cosmic mist. To others, they were just nearby clouds. But a suspicion grew. Maybe the universe was not static. Maybe it was changing, slowly but surely. By the late 19th century, the tools grew sharper. Spectroscopy, the science of splitting light into its rainbow, revealed hidden messages in starlight. You may have seen this effect yourself in raindrops or a prism, but astronomers used it like a code. Each element, hydrogen, helium, oxygen, left its own fingerprint in light. By studying those fingerprints, scientists could tell what stars were made of. More importantly, they could tell if a star was moving toward or away from us, because the fingerprints shifted slightly, stretched or compressed by motion. This was not glamorous work. Imagine peering through telescopes, adjusting instruments in cold domes, staring at faint lines on photographic plates, comparing them with reference charts. The kind of work that could put you to sleep if you weren't careful. And yet, these dull details began whispering something extraordinary. Many stars and nebulae seemed to be drifting away from us. Their fingerprints were stretched redshifted, suggesting they were receding. For centuries, people had assumed the heavens were fixed. But here was evidence of motion on a cosmic scale. The sky was not still. It was alive with movement. At the same time, mathematics was quietly catching up. In the early 20th century, Albert Einstein developed his general theory of relativity, a framework that described how space and time bend and stretch under gravity. His equations suggested that the universe itself could not be perfectly static. Like a rubber sheet under pressure, it had to be either expanding or contracting. Einstein himself disliked this. He wanted a calm, eternal cosmos, not one that grew or shrank. To keep things steady, he added a term to his equations, a cosmological constant, essentially forcing the math to hold still. It was, in hindsight, a patch away of clinging to eternity in a universe that didn't seem to want it. Meanwhile, astronomers with long nights and glass plates were doing the unglamorous work of photographing the sky, cataloguing nebulae, and measuring their faint spectra. These nebulae, once thought to be small nearby clouds, turned out to be far more distant and far more numerous than anyone suspected. By the 1920s, it became increasingly clear that some of them were not clouds at all, but entire galaxies, vast systems of stars, like our own Milky Way. And here was the astonishing detail. Many of those galaxies showed the same redshift pattern. They were moving away. Step back and think about what this means. If galaxies are moving away, then the universe is not static, it is stretching. And if it is stretching now, then perhaps at some earlier time it was smaller, more compact, maybe even compressed into a beginning. Suddenly, the possibility of a universe without beginning and without end seemed less certain. Expansion hinted at a story, a direction, maybe even a first page. It's easy to take this for granted now, lying here in the 21st century, knowing the phrase Big Bang and imagining galaxies racing apart. But at the time, it was deeply unsettling. For generations, the eternal universe had been assumed, even cherished. The idea that the cosmos might be expanding, might even have a beginning, felt like pulling the rug out from under human understanding, and yet, it was the dull details that carried the weight. Not dramatic flashes in the sky, not myths or visions, but quiet shifts in spectral lines. Long nights in observatories, faint smudges of light measured on glass. Astronomers bent over charts, sipping coffee in the cold. The universe whispered its secret, not in thunder, but in numbers. This period, the late 19th and early 20th centuries, was a kind of twilight zone for cosmology. On one side stood the ancient idea of eternity, the stars eternal, the cosmos without beginning. On the other stood these new hints, nebulae as galaxies, galaxies drifting apart, equations refusing to sit still. Nobody had yet put it all together, but the foundation was being laid, quietly, detail by detail. It's worth pausing here to notice something important. Science often moves not in leaps but in slow, grinding steps. For centuries, the night sky had been assumed eternal. It took the patient work of counting, mapping, and measuring to reveal its restlessness. You could say the universe's greatest secret, that it might not be eternal, was hidden in boredom. For you, lying back and listening, this might be a comforting thought. The people who revealed the universe's expansion were not chasing glory. They were simply doing their work, carefully, repetitively, almost sleepily. And yet, by honoring those dull details, they cracked open one of the biggest questions of all. Does the universe have a beginning? So here the stage is set. The myths of eternity are still alive. The night sky's darkness is still puzzling. But now, the galaxies themselves seem to be slipping away, as though pulled by some invisible tide, and the question grows louder. If everything is moving apart, where did it all come from? As you drift deeper into thought, consider this. When you watch something expand, like ripples in water or a balloon filling with air, you instinctively imagine a beginning. But if the universe itself is expanding, does that mean it had to be inflated from a first moment? Or is there still some way to imagine eternity hiding behind the movement? Imagine Albert Einstein in the early 1920s, standing at a chalkboard, his equations sprawled across the surface in curling chalk marks. He has just completed what many consider the most beautiful theory in physics, general relativity. It explains how space and time bend under the influence of mass and energy. It suggests that planets move not because of invisible forces pulling them, but because they are sliding along curves in space-time. For most people, this would have been enough a triumph so great that it reshaped physics. But hidden in those equations was something Einstein himself could not accept. The math pointed toward a universe that was not sitting still. It wanted to expand or contract. To Einstein, this felt wrong. For centuries, philosophers, theologians, and scientists alike had leaned on the idea of a steady, eternal cosmos. The stars overhead were not just distant lights, they were symbols of permanence. To suggest otherwise, that the entire fabric of the cosmos could be changing, felt almost absurd. So Einstein did something curious. He adjusted his equations. He introduced a small fudge factor called the cosmological constant. It was, in essence, a patch away to hold the universe still when the math was trying to make it move. Imagine tightening the lid of a jar that insists on bulging outward. That was Einstein's constant, a way of enforcing eternal stability in a universe that seemed to resist it. What's remarkable is not just the choice, but the reason behind it. Einstein was not being sloppy. He was being cautious. A dynamic universe felt too wild, too speculative. He believed the cosmos must be eternal, balanced, infinite in time and space. To suggest otherwise felt like walking out on a limb without support. After all, there was no observational evidence yet that the universe was expanding. Why throw away centuries of comfort for equations that might be misleading? Meanwhile, far from Einstein's blackboards, astronomers continued their plodding work. Observatories filled their archives with photographs of faint galaxies. Spectral lines, shifted ever so slightly toward the red, were carefully catalogued. The evidence was piling up, quietly, like water behind a dam. But Einstein was not looking at those photographs. He trusted his own sense of what the universe should be. It is strangely human, isn't it? Even the greatest thinker of the age resisted a discovery because it clashed with intuition. You might picture him late at night, staring at those chalked equations, deciding to add one extra term to keep the cosmos from wobbling. Perhaps he felt relief. Perhaps he thought he was protecting physics from running off into speculation. But what he really did was delay acceptance of something profound, that the universe might have a beginning. In hindsight, Einstein would call this his greatest mistake, not because the constant itself was bad math. It has returned in modern cosmology in a different role, but because he clung to the idea of eternity. When the evidence was already shifting, he trusted comfort over discomfort. This story matters because it reveals something about science. Progress is not a straight march forward. It is messy. It involves personalities, preferences, even stubbornness. If you have ever ignored a fact because it didn't fit your expectations, you've done exactly what Einstein did. His genius did not shield him from the most human of habits, holding on to what feels safe. Now picture the world in those years. The 1920s were roaring, cities glowing with electric lights, cars filling the streets, radios buzzing with jazz, and in observatories far from the noise, astronomers were studying galaxies. In California, Edwin Hubble was comparing photographs of spiral nebulae, carefully measuring how bright they were and how far away they might be. He noticed something extraordinary. The farther away a galaxy seemed, the faster it was receding. This was the nail in the coffin for a static universe. The cosmos was not fixed. It was expanding. When news of Hubble's results reached Einstein, he traveled to California to meet him. Standing on Mount Wilson, Einstein peered through the great telescope that had revealed the distant galaxies. He could no longer deny it. The universe was not eternal and still. It was stretching outward, carrying galaxies away from one another like raisins in rising dough. It must have been humbling. The man who had reshaped physics with pure thought experiments had overlooked the quiet, boring data of astronomers with photographic plates. Expansion was not just a possibility, it was reality. His cosmological constant had been unnecessary, even misleading. And so, years later, he would confess that this insistence on a static universe had been his biggest blunder. But pause here. There is something fascinating about the contrast. On one side, the slow, tedious measurements of light shifts in galaxies. On the other, the grand elegance of Einstein's equations. Both were paths to truth, but they did not meet until stubbornness gave way. The expanding universe was discovered not in a flash of inspiration, but in the grinding alignment of theory and observation. For you, lying there and listening, this may feel strangely comforting. Even in science, even at the highest levels, mistakes are part of the process. The universe did not reveal itself easily. It had to be coaxed, argued over, doubted, and finally admitted. The idea of eternity had such a grip that even when the math and the measurements disagreed, it lingered. Think of it this way. Imagine if Einstein had trusted his equations fully from the start. He might have predicted expansion before anyone measured it. He might have been celebrated not just for relativity, but for anticipating the dynamic universe. Instead, he hesitated. And in that hesitation, we see ourselves. We see the human tendency to cling to what feels stable, even when the truth is stretching out in front of us. The irony is that the cosmological constant would later return, not as a patch to keep the universe still, but as a way to explain why expansion seems to be accelerating. But that part of the story comes much later. For now, in the 1920s, the shock was fresh. The universe had betrayed its reputation for eternity. It was moving, stretching, perhaps even beginning. And here is where the question grows sharper. If the universe is expanding now, what happens if you wind the clock backward? Does everything converge to a single point? Does that imply a beginning, a birth, a cosmic dawn? Or is there still some way to imagine it without edges, without a first moment? By the early 1930s, the universe was no longer behaving politely. The galaxies were racing away from one another, and the evidence was too plain to ignore. The telescope photographs, the spectral shifts, the careful measurements, all of it whispered the same conclusion. Expansion was real. The universe was stretching, and this, naturally, raised an uncomfortable question. If it is expanding now, then what was it doing in the past? The thought was like tugging on a thread and finding the whole sweater unravel. If you rewound the cosmic clock, those galaxies would not just approach one another, they would collide, merge, compress. Wind it back far enough, and everything, the stars, the dust, the matter of your body, the atoms in your bones would have been packed into something unimaginably small and dense. It implied a beginning, not a calm eternity, but a fiery birth. It was Father Georges Lemaitre, a Belgian priest and physicist, who dared to say it plainly. In 1927, he published a paper suggesting that the universe had started from what he called a primeval atom. He pictured all of space compressed into a single point, which then exploded outward in a grand expansion. Today we call it the Big Bang, but at the time, it was a shocking and even scandalous idea. The scientific community reacted with unease. Many preferred the idea of a steady-state cosmos, one that was eternal and unchanging in its grand design. The steady-state model was tidy. Galaxies might drift apart, but new matter would simply form to fill the gaps, preserving balance forever. It meant no beginning, no end, just an eternal cycling of creation. It felt safer, less radical, more in line with tradition. For Lemaitre, though, the math was unavoidable. The expansion discovered by Hubble, the framework of relativity, and the logic of rewinding time all pointed to the same conclusion. The universe had a starting moment. Imagine him explaining this, perhaps with quiet conviction, reminding colleagues that data was not something to ignore. He did not see a conflict between his religious beliefs and the science. To him, a beginning was natural. But to many physicists, it felt dangerously close to theology, an invasion of faith into the clean world of equations. The irony was sharp. Those who opposed the Big Bang sometimes did so not because the science was weak, but because they feared it resembled religious creation stories. The idea of a cosmos with a beginning smacked of Genesis, of divine sparks, of myths they were eager to leave behind. Science, they thought, should not entertain beginnings. It should describe an eternal framework, a cosmos without a birthday. And yet, the evidence kept growing. The galaxies moved as if they had once been together. Their flight outward was too orderly, too consistent to be mere coincidence. It was as if the universe itself carried the memory of its own birth in the momentum of its expansion. Still, resistance lingered. You can almost picture the debates, conducted in stuffy lecture halls and on the pages of dense journals. One camp clung to eternity, the other to a cosmic dawn. Neither side could prove their case completely, and so the arguments simmered. During the 1940s and 50s, the steady-state theory gained clever champions, including the brilliant Fred Hoyle. He argued that as the universe expanded, matter must continually pop into existence to keep its density constant. It was an elegant idea, requiring no beginning, no abrupt moment of creation. To him, the Big Bang sounded crude, like an explosion in a laboratory. He even coined the phrase Big Bang as a mocking nickname, yet the insult stuck, eventually becoming the accepted name for the very theory he dismissed. Think of the stubbornness here. Entire careers were built on keeping the universe eternal. It was not just a scientific position, but an emotional refuge. Eternity meant safety, permanence, the absence of a starting gun. Beginnings felt messy, intrusive, suggestive of mysteries beyond equations. But science is relentless. In the 1960s, radio astronomers stumbled upon something extraordinary, a faint hiss of microwave radiation coming from every direction in the sky. It was not noise from the Earth, nor from the galaxy, but from the cosmos itself. It was a glow, a residue, a whisper left over from something unimaginably hot and dense in the distant past. This was the cosmic microwave background, and it was the smoking gun of the Big Bang. Suddenly, the steady-state model collapsed. No eternal cycling could produce such a signal. Only a universe born in fire could leave behind this cooling afterglow. It was as if the cosmos had been trying to tell us all along, and only then did we finally hear it. For you, listening now, there's something almost humorous in how long it took. The expansion had been discovered in the 1920s, the idea proposed by Lemaitre, the nickname coined by Hoyle, and yet decades of wrangling were needed before the evidence shouted loud enough to quiet the doubts. Science, it turns out, is not just about data, it is about pride, hesitation, habits of thought, and the slow erosion of resistance. The Big Bang did more than provide a beginning. It reshaped the entire narrative of existence. Suddenly, questions that had been philosophical, where did everything come from, and when were scientific? The cosmos had a childhood. It had a temperature, a density, a trajectory. It was not eternal marble but unfolding history. Imagine lying back and realizing this. The air you breathe, the pillow beneath your head, the walls of your room, the voice you hear, all of it was once compressed into a volume smaller than a grain of sand. The calmness of your evening is a far echo of that violent birth. You are, in a sense, a cooled fragment of a cosmic eruption. And yet, even this conclusion left space for unease. If the universe had a beginning, what was before? Was there truly nothing? Could there ever be nothing? Or was the beginning itself just one act in a cycle larger than we can see? So here you are, lying in your room, letting your mind drift across billions of years. The clock ticks softly beside you, but in your imagination, time runs backward again past the birth of stars, past the clustering of galaxies, past even the spreading of space itself, until you arrive at those first seconds after the Big Bang. Not the bang itself, but the immediate aftermath, the newborn heartbeat of the cosmos. Scientists often begin the story at a point called 1 second. By then, the universe was unimaginably hot, trillions of degrees, but already cooling from something even worse. In that boiling sea of energy, particles bubbled into existence. Protons, neutrons, and electrons, tiny things that, combined much later, would make up you, me, and everything else swam like frantic minnows in a cosmic soup. The dullest part of this story might also be the most significant: the ratio of protons to neutrons. It sounds unremarkable, almost bureaucratic, like a forgotten line in a government document. Yet that tiny balance decided the chemistry of the universe. Too many neutrons, and everything collapses into heavy elements. Too many protons and atoms never quite form. But here, in those first 3 minutes, the proportions were just right. Out of boredom, perhaps, hydrogen and helium were born. Hydrogen, the simplest atom, with 1 proton at its heart. Helium, with 2 protons and 2 neutrons bound together. Together, they made up almost everything. Even now, all the galaxies and stars you see are 99% hydrogen and helium. Every future flame, every glowing star, every atom in your breath depended on that bland arithmetic from the very beginning. And then there is the afterglow, the cosmic microwave background, which we mentioned earlier. By about 380,000 years after the Big Bang, the universe had cooled enough for atoms to actually hold together. Electrons were no longer yanked apart by the intense heat. Suddenly, the cosmos became transparent. Light, once trapped in fog, was free to travel. That faint glow of radiation, still detectable today as a quiet hiss in radio telescopes, is the fossil light of that moment. It is the universe's baby picture, plain and unavoidable. Scientists studying it often describe it as boring, full of slight fluctuations, and almost uniform warmth, yet in those tiny fluctuations, imperfections, smaller than a grain of sand on a football field, lay the seeds of galaxies, stars, and planets. The universe was almost perfect, but not quite, and that tiny imbalance allowed clumps of matter to form. You might say, imperfection is the reason you exist at all. Think for a moment about the strange calmness of these numbers. The background radiation has a temperature of 2.7 Kelvin, just above absolute zero. A dull statistic perhaps, but this quiet coolness blankets the sky. If you could tune your television to static in the old days, a fraction of that noise came directly from the Big Bang itself. Sitting on your couch, flipping channels, you were unknowingly watching the ghost of creation. It is remarkable, isn't it, how such grand truths hide in such ordinary details. Ratios of particles, degrees of temperature, faint hisses of radiation. The entire structure of galaxies and stars, the birth of chemistry, the emergence of life, all of it emerged from these subtle, almost boring balances. And scientists, of course, could not resist trying to dig deeper. They began to reconstruct not just seconds and minutes after the Big Bang, but fractions of seconds, unimaginably small slices of time. They spoke of inflation, a sudden expansion that happened so quickly it defies intuition. In less than the blink of an eye, the universe ballooned from something smaller than a proton to something vast and smooth. Why did it do this? No one really knows. The mathematics suggests it, the evidence hints at it, but the cause is hidden, perhaps forever. Inflation solved certain puzzles, like why the universe looks so uniform in every direction. Without it, there was not enough time for distant regions of space to even know about each other. Inflation stretched everything so much that differences smoothed away, like dough rolled flat by an invisible hand. And yet, as always, there is mystery. What triggered inflation? What ended it? Was it a one-time event? Or does it happen again and again, spawning countless universes like bubbles in an endless sea? For you, lying comfortably, these questions might feel pleasantly abstract. You can imagine bubbles rising in boiling water, each one a universe, ours among them. You can picture the afterglow still streaming across the night sky, invisible to your eyes but present all the same. You can even smile at the thought that every breath of air you take, every molecule of water you sip, carries a lineage stretching back to those first minutes. The Big Bang Theory, refined through these observations, became less of a wild idea and more of a precise map. Scientists could say, with remarkable confidence, how much hydrogen, helium, and lithium should exist. They could measure the background radiation and compare it to predictions. Again and again, the data matched. The story, however unbelievable, was written into the universe itself, but the questions refused to stop. If the universe began this way, does that mean it must also have an end? If it is expanding, will it expand forever? Or will gravity someday tug it back, collapsing everything in a reverse bang? And, most unsettling of all, what does it mean to talk about before the beginning? Even the calmest scientist must pause here. Before time began, before space stretched, can before even exist without time to measure it? The very grammar of our thoughts seems to falter at the edges of this mystery. And so, as you close your eyes and let your breathing slow, you find yourself in good company. The greatest minds of the last century have done the same. Einstein, Lemaitre, Hoyle, and countless others, all turning these questions over like stones in a river, smooth and worn, yet endlessly intriguing. Perhaps the universe is trying to tell us that the beginnings are always partly hidden, that even with our best telescopes, we are peering through a glass darkly. Or perhaps it is only reminding us that curiosity itself is the real engine of discovery. By the middle of the 20th century, astronomers had become accustomed to surprises. They had accepted that the universe expanded, that it had a fiery birth, and that the afterglow of creation still lingered across the sky. Yet the cosmos was not done whispering secrets. The stars we could see, those shining points overhead, were only a tiny fraction of what existed. Most of the universe, it turned out, was invisible. The first hints came quietly, through careful observation of galaxies. In the 1930s, a Swiss astronomer named Fritz Zwicky studied clusters of galaxies. He measured how fast the galaxies moved and compared it to the mass visible in stars. To his surprise, the galaxies were moving far too quickly to be held together by the gravity of the stars alone. There had to be more mass, vast amounts that could not be seen. He called it dunkel materie, or dark matter. Think about that for a moment. Entire galaxies, vast collections of billions of stars, were being pulled around by something we could not detect. The visible universe, the dazzling points of light we so often admire, was only a tiny fraction of reality. The rest was hidden, silently shaping the motion of everything we could see. For decades, Zwicky's discovery was largely ignored. It was a dull, almost boring conclusion, from dull, almost boring measurements. There were no explosions, no cosmic drama, just numbers, velocities, and gravitation calculations that stubbornly refused to match the stars alone. Only later, as astronomers refined their measurements and studied galaxy rotation curves, did the reality of dark matter become undeniable. Picture it like this. Imagine a carousel spinning with horses you can see. If you calculate the forces and speeds of the horses, the carousel should tear itself apart. But it doesn't. Something invisible, some hidden weight, keeps it moving smoothly. That is dark matter, the unseen glue holding galaxies together. And then, as if one mystery were not enough, another began to emerge in the 1990s. Observations of distant supernovae revealed something even stranger. Not only was the universe expanding, but the expansion was accelerating. Galaxies were moving apart faster and faster, as though propelled by some invisible force. Scientists called it dark energy. Now the picture became deeply unsettling. Most of the universe is not stars, not planets, not anything you can see. About 70% of the cosmos is dark energy, the mysterious driver of acceleration. About 25% is dark matter, holding structures together. Less than 5%, the tiny fraction that fills your bedroom ceiling with visible stars, is what we normally think of as the universe. This is one of those dull but profoundly disturbing facts. The universe is not made mostly of matter, nor is it simple. Most of what exists is invisible, unknowable by ordinary senses. And yet, the motions of galaxies, the shape of cosmic structures, the ripples in the microwave background, all of it carries the fingerprints of these unseen components. Consider the absurdity of it. You spend your life surrounded by ordinary matter, chairs, water, air, computers, but the real scaffolding of the universe, the vast invisible framework, is something you cannot touch, taste, or see. Dark matter and dark energy are like the quiet backstage crew of a cosmic play. They move the scenery, shape the actors, and set the scene, yet they remain unseen, unacknowledged, silent. Astronomers measure their effects with precision. Gravitational lensing, the bending of light around massive objects, reveals dark matter's presence. Supernova brightness and galaxy clustering reveal dark energy's push. Yet what these substances actually are remains mysterious. Are they particles, fields, properties of space itself? The universe refuses to answer. For you lying back, the lesson is clear. The universe is stranger than even the most imaginative myths. The afterglow of the Big Bang, the expansion of galaxies, the ratios of hydrogen and helium, all of it is only part of the story. The bulk of existence remains hidden, quietly governing the cosmos. It is a reminder that what we see is not the whole truth, that reality often hides behind mundane measurements, subtle calculations, and quiet persistence. And perhaps there is a poetic irony here. Humanity has spent millennia looking up at the stars, imagining eternity, beginnings, and ends. We invented myths, measured light, calculated spectra, and eventually detected the whisper of creation itself. Yet when we peer more deeply, we discover that most of it is invisible, unknown, and perhaps unknowable. The cosmos has been playing a quiet trick on us all along, revealing profound truths only to those patient enough to notice the boring details. As always, questions remain. What is dark matter made of? How does dark energy work? Will the universe expand forever, driven by this invisible force, or will some future cosmic change alter the trajectory? Even now, each observation raises new puzzles. The universe is no longer a simple stage with stars as actors. It is a vast, hidden machinery, much of it invisible, all of it profound. For you, drifting towards sleep, consider the quiet absurdity. You are breathing molecules forged in stars, in a cosmos mostly invisible, governed by forces you cannot detect with your senses. The universe is older, stranger, and more mysterious than any myth could capture. And yet, these mundane measurements, redshifts, rotation curves, faint background radiation carry the deepest truths. The boring, dull work of patient observation reveals the spine of reality. And so the story grows. From myths to observations, from Einstein's equations to the faint hiss of the microwave background, from the fiery seconds after the Big Bang to the invisible scaffolding of dark matter and dark energy, the universe continues to challenge expectations. It refuses to be simple. It refuses to be fully known. And it leaves you, quietly, with the most basic, unavoidable question. What is really out there? As you lie there, the quiet of your room enveloping you, it is easy to imagine the universe as something stable, eternal, unchanging. But the discoveries of the 20th century remind us that the cosmos is restless. It expands, it cools, and it evolves. And like any living process, it must have a destiny, a future that stretches beyond our comprehension. Let's begin with one possibility: heat death. It is not the dramatic, fiery apocalypse movies love to show. There will be no explosions, no collapsing planets, no screams echoing across space. Instead, it is a slow, almost boring fading of energy. Over billions, trillions, or even more years, stars will burn out, galaxies will drift apart, and matter will cool to near absolute zero. Light itself will become scarce. The universe will become a dark, cold, quiet place. You, listening comfortably tonight, can picture a time when even starlight has gone, leaving only a faint background of particles drifting lazily through empty space. This scenario is strangely poetic. The universe, born in a fiery, chaotic moment, will eventually settle into silence. Every atom, every particle, every galaxy will persist, but in a state of near-perfect equilibrium. No energy gradients, no movement, no work to be done. Life, as we know it, would be impossible. The cosmos would be a serene emptiness, a vast and gentle fading away. But there are other possibilities, equally mind-bending. Imagine the Big Crunch. In this scenario, the expansion of the universe, now driven by dark energy, eventually reverses. Gravity overcomes the outward push, pulling galaxies back together. Slowly at first, then faster and faster, the cosmos collapses inward. Stars collide, galaxies merge. Matter compacts. Eventually, all the universe condenses into an incomprehensibly dense point, perhaps similar to the state before the Big Bang. In this scenario, the universe ends not in quiet darkness, but in an almost unimaginable compression. And yet, we have another scenario. The universe might expand forever. Galaxies will drift further apart, stars will burn out, and space itself will stretch indefinitely. This scenario, sometimes called the Big Freeze, shares similarities with heat death, but emphasizes the relentless growth of the cosmic fabric. Distances will become so vast that galaxies beyond our own will vanish from sight. The night sky will grow emptier, quieter, lonelier. Even time may seem to slow, as events become rarer and the universe stretches toward an infinite cold horizon. Each of these fates carries subtle, profound implications. If the universe ends quietly, in heat death, it suggests a finite process unfolding toward equilibrium. If it collapses, it hints at cycles, possibly repeated expansions and contractions. If it stretches forever, it raises questions about infinity and the meaning of an endless cosmos. In every case, the night sky you see tonight, so full of wonder, becomes a fleeting phenomenon, temporary and delicate against the backdrop of cosmic time. And here's a subtle thought. For much of human history, people assumed the universe had no beginning and no end. Eternity was comforting, reassuring. Yet modern science, by measuring expansion rates, studying the microwave background, and probing dark energy, suggests that eternity may be an illusion. The universe had a beginning, and it will likely have an end. Even if that end is unimaginably distant, it exists in principle. What feels infinite to our minds may, in fact, be bound by physical reality. Let's return for a moment to the night sky. The stars you see are mostly within your galaxy, a tiny collection of matter in a vast expanse. Beyond them, galaxies drift away, unseen or barely visible. Even now, some light from distant galaxies may never reach you. In the distant future, the universe will expand so much that no other galaxies will be visible at all. From that perspective, the cosmos may appear empty, lonely, and eternal in a deceptive way. Infinity can be an illusion when distances and timescales are vast enough. And yet, even within these outcomes, there is something strangely calm. The universe does not explode violently, nor does it collapse chaotically in most scenarios. It unfolds in a quiet, measured progression dictated by laws of physics, by forces both visible and invisible. The cosmos is not capricious. It is patient, predictable in its large-scale behavior, even if the details are astonishing. Consider also what this means for us. Life, consciousness, stars, planets, they are temporary phenomena. You, lying in bed tonight, are part of this fleeting chapter in a vast story. And that perspective is not meant to be frightening. It is liberating. In a universe that will eventually end, every moment of awareness, every observation, every curiosity becomes more significant, not less. Your consciousness is a brief spark in an immense timeline, and in that, there is wonder. This leads to an intriguing question. If the universe has both a beginning and a foreseeable end, what is the nature of existence in between? Are beginnings and ends purely physical, like the first spark of a fire and the last ember fading? Or is there something deeper, a pattern, a continuity that transcends the expansion and cooling of matter? Science cannot answer this definitively, but it allows you to imagine, to ponder, to drift into the quiet majesty of cosmic time. And finally, there is the unsettling, subtle possibility. What if the end is not as simple as we predict? Dark energy itself is mysterious. Perhaps its properties will change. Perhaps new physics will emerge that we cannot yet foresee. Even the most boring, routine observations, measuring galaxy motion, recording background radiation, analyzing particle collisions could one day overturn our understanding. The universe may have hidden surprises yet to come, waiting for the patient, the curious, the sleepy minds willing to notice. So, as you settle further into comfort, the cosmos stretches before you, expanding, evolving, aging. Its stars and galaxies are temporary patterns in the larger fabric of space and time. Its invisible forces, dark matter and dark energy, silently govern its fate. Its beginning, once mysterious, is now understood in broad strokes. Its end remains uncertain, but constrained by the same laws that have carried it through billions of years. And yet, even with all this knowledge, one question persists. If the universe is temporary, if it has a beginning and will have an end, what does that mean for the concept of eternity itself? Can anything truly exist without beginning or end? Or is eternity merely a comforting idea, forever beyond our grasp? Imagine the universe not as a straight line from beginning to end, but as a rhythm, a pulse, a cycle stretching beyond comprehension. This idea, the cyclic universe, has quietly persisted through centuries, from ancient philosophical speculation to modern theoretical physics. Instead of a singular beginning or final end, the cosmos could be caught in an endless dance of birth, expansion, collapse, and rebirth. For most of human history, eternity was imagined as a steady state, unchanging and infinite. The idea of cycles, however, adds motion, a rhythm. Ancient cultures often imagined cosmic cycles in myths. Creation, emerging from chaos, then dissolving, only to rise again. Modern science, with its precise equations and careful observations, approaches a similar concept, albeit stripped of mythology and clothed in mathematics. One framework for the cyclic universe comes from imagining a series of big bangs and big crunches. As we discussed earlier, gravity could, in principle, eventually reverse expansion, drawing galaxies back together into a dense, compact state. If the universe does collapse, could it bounce back once more, igniting a new expansion? In this view, what we perceive as a beginning might merely be the latest act in a much longer story. The mathematics supporting this idea is subtle and demanding. It involves general relativity, quantum mechanics, and hypothetical forms of energy and matter that we cannot yet fully detect. Physicists like Paul Steinhardt and Neil Turok have explored models where the universe undergoes endless cycles, each one stretching and cooling, compressing and igniting, like a heartbeat on a cosmic scale. Each cycle could last trillions of years, too long for human comprehension, yet governed by the same unchanging laws of physics. Consider the profound implications. If the universe is cyclic, then perhaps the question of a singular beginning loses its sting. The Big Bang, instead of a unique event, becomes a phase, a moment in an eternal rhythm. The end, too, becomes relative. The cosmos expands, contracts, and expands again. Eternity is no longer linear, it is circular, like a cosmic Ouroboros, devouring itself only to emerge anew. And yet, the details matter. Cyclic models are not easy to reconcile with everything we observe. For instance, the accelerating expansion driven by dark energy poses a challenge. If space continues to stretch faster and faster, will gravity ever reclaim enough influence to trigger a contraction? Some theorists imagine that dark energy itself might change over time, weakening or reversing, allowing cycles to continue. Others suggest entirely new physics yet to be discovered. There is a beauty in this uncertainty. Just as the universe defies easy perception on a vast scale, it resists simple conclusions in our theoretical models. The equations are precise, yet incomplete. The predictions are elegant, yet provisional. The cosmos, even in theory, preserves a sense of mystery. Think for a moment about what this means for existence. Each particle, each star, each galaxy could be part of countless cycles. Perhaps the atoms in your body have survived multiple cosmic expansions and contractions. Perhaps the structures you see in the night sky are echoes of long-forgotten cycles, each expansion carrying forward subtle imprints of what came before. It is a humbling, almost dizzying thought. And yet, the idea is not purely abstract. Observations of the cosmic microwave background, galaxy distribution, and particle behavior all serve as tests for these theories. Physicists sift through massive datasets, looking for tiny anomalies, minute patterns that might hint at prior cycles. The work is painstaking, repetitive, and slow. Nights in observatories, days at computer terminals, endless simulations. All of it builds toward glimpsing evidence for a rhythm that may stretch beyond human comprehension. This interplay of theory and observation mirrors the earlier story of the expanding universe. Just as astronomers once ignored Zwicky's dark matter, so too might some scientists have dismissed hints of cyclic behavior. The universe communicates not in fireworks, but in subtlety. It is patient, allowing only the persistent, the attentive, the curious to detect its secrets. From a philosophical perspective, the cyclic universe restores a kind of comfort. If existence repeats endlessly, then beginnings and ends are not final. Life, consciousness, stars, and galaxies are part of an eternal recurrence, a cosmic pattern with neither true origin nor ultimate conclusion. The universe becomes less a static backdrop and more a living rhythm, expanding and contracting like a slow, celestial breathing. Yet the mystery remains. Even in a cyclic model, questions linger. Are the cycles identical, or do they differ each time? Does entropy accumulate across cycles, subtly altering the universe with each pass? Are there infinite possibilities, or does the cosmos eventually repeat precisely, like a record stuck on a loop? These questions, as always, resist final answers. For you, lying back and listening, this may be comforting or unsettling. The universe may have no ultimate beginning or end, yet it is still governed by laws and rhythms. It may unfold endlessly, yet each moment remains fleeting, precious, and significant. Time, expansion, birth, collapse, all may be part of a pattern larger than we can imagine, yet intimately connected to every particle you perceive and every thought you have. And so, even as your eyelids grow heavy, consider this. If the universe is cyclic, then your curiosity, your attention, your very consciousness is part of an endless rhythm. Each question you ask, each fact you ponder, is a ripple in the ongoing pulse of existence. You are both temporary and eternal in a strange, quiet way. Finally, we return to the core question. If the universe has no beginning or end, what does that imply about time itself? Does it flow linearly, or does it curve back on itself like a circle? Can we ever fully understand it, or is eternity something we glimpse only indirectly, through patient observation and imagination? Imagine, for a moment, that our universe, the stars, galaxies, planets, and even your bedroom right now, is only a single bubble in a vast, unimaginable sea of existence. This is the idea behind the multiverse, a concept that stretches the imagination and challenges our most basic assumptions about reality. In this vision, what we call the universe is just one of countless others, each with its own laws, its own beginnings, perhaps even its own destinies. The concept of multiple universes is not merely science fiction, it emerges from serious theoretical physics. Some theories of cosmic inflation suggest that, as our universe expanded rapidly in its first fractions of a second, pockets of space could have budded off, forming entirely separate universes. Each bubble could expand independently, with its own constants, its own dimensions, its own version of physics. In such a scenario, the universe as you know it is just one among countless siblings, drifting quietly in an unseen multiverse. For centuries, humans assumed that the cosmos was a single entity. We measured stars, mapped galaxies, and imagined eternity as a continuous, infinite space. But the multiverse shatters that simplicity. It suggests that infinity might exist not just in time, but in variety, infinite possibilities, infinite variations, each universe a small experiment in cosmic law. Consider what this means for beginnings and endings. If there are countless universes, each may have its own birth, its own expansion, its own evolution. Some may collapse quickly, others may expand endlessly. Some may never form stars at all, while others might develop structures far stranger than our own. In such a reality, the question of a single beginning or a single end loses meaning. Creation is not a singular moment but a continual process, playing out across an endless landscape of universes. One of the intriguing aspects of multiverse theories is how they emerge from the same physics that describes our own universe. Cosmic inflation, quantum fluctuations, and even string theory hint at mechanisms that could generate multiple universes. In each case, the mathematics points toward vast possibilities, but observation is difficult, if not impossible. You cannot peer into another universe, at least with current technology. Their existence must be inferred indirectly, through subtle consequences, or by the strange fine-tuning of our own cosmic constants. Imagine lying back and thinking about this for a moment. The faint glow of distant galaxies, the microwave background, even the light from your bedside lamp. These are part of a universe that is real to you, tangible in a way. But beyond that bubble lies an infinite landscape of other universes, each invisible, perhaps imperceptible, yet no less real. Your imagination, then, becomes a kind of telescope, stretching into a reality that may never be directly observed. And here is a subtly unsettling idea. If there are infinite universes, then every possibility, no matter how improbable, might exist somewhere. Somewhere out there, a universe exists where the laws of physics are reversed, where life takes an entirely different form, or where stars burn in colors you cannot even imagine. In that sense, eternity and infinity are woven together. There may be no beginning and no end, not just for our universe, but for the entire multiverse. This perspective also reframes our understanding of significance. If every possible outcome exists somewhere in the multiverse, does that make our choices or our universe less important? Or does it make them uniquely precious? Because this is the bubble you inhabit, the reality you experience, however improbable or ordinary it may seem. The multiverse expands the scale of existence, yet it does not diminish the immediacy of your life here and now. Of course, this idea is controversial. Some scientists worry that multiverse theories cannot be tested, that they verge on speculation. But others argue that the implications of known physics naturally point in this direction. Quantum mechanics, cosmic inflation, and string theory all hint at realities beyond our observable horizon. It is not fantasy, it is a logical, if dizzying, consequence of our best theories. Think of it like standing at the edge of a pond. You see ripples on the surface, measure their speed, watch how they interact. You might deduce the presence of hidden currents beneath, currents that shape the pond but remain unseen. The multiverse is like the infinite hidden currents of reality, shaping existence in ways we cannot perceive, but whose effects ripple into the universe we inhabit. And then there is the subtle, almost poetic idea of eternal recurrence. In a multiverse with infinite variations, every cosmic cycle, every beginning, every end, may be played out somewhere else. Perhaps universes emerge, expand, fade, and collapse over and over across an infinite tapestry. In this context, the notion of a beginning or end becomes relative. What feels like birth in one bubble may be just a moment in an eternal process spanning countless realities. For you, lying comfortably and listening, this can feel both humbling and liberating. The universe, you know, is vast, astonishing, and mysterious, but it may be only a single note in an infinite symphony. Your curiosity, your imagination, your very consciousness connects to something that stretches beyond time, beyond space, beyond the boundaries of what can be directly observed. And yet, the multiverse also leaves room for reflection. If beginnings and ends are relative, if our universe is one bubble among countless others, how do we understand causality, meaning, and significance? How do we grasp the nature of reality when even the most basic concepts, space, time, matter, may differ elsewhere? The answers are uncertain, and perhaps they must remain so. Some questions exist to expand your thinking, to deepen your awareness of the cosmos, rather than to be conclusively answered. Finally, consider a quiet, personal thought. The multiverse is not just an abstract concept. It is a reminder that the cosmos is stranger, larger, and more intricate than we can perceive. That our universe may have no ultimate beginning or end is part of the larger truth. Reality itself is richer, deeper, and more complex than our senses can comprehend. And in that subtle, almost invisible truth lies wonder. As you lie there, listening and breathing softly, it is natural to wonder not only about the physics of the universe, but about what it means for us. A cosmos with no beginning and no end challenges more than equations, it challenges thought itself. Humans have long struggled with the concepts of infinity and eternity, concepts that seem almost impossible to grasp, yet that shape how we understand existence. In ancient times, philosophers debated whether the universe had always existed. Some, like Aristotle, believed in an eternal cosmos, unchanging in essence, without beginning or end. For him, the stars, planets, and heavens were part of a perpetual, balanced system. Change existed, of course, but the cosmos itself was permanent, a vast, unending order. Imagine living with such a worldview, where every generation stood beneath the same eternal heavens, the same steady stars, confident that nothing had truly started and nothing would truly end. Other thinkers imagined cycles. The ancient Hindus spoke of kalpas, enormous cycles of creation, preservation, and dissolution. The Greeks spoke of ages and repetitions. Even without modern telescopes, these early ideas hint at an intuitive understanding. The universe may be vast, deep, and repetitive, beyond the span of any human life. These are philosophical attempts to wrestle with infinity, to place the fleeting human experience within something larger. Fast forward to the modern era. Now, the eternity or finitude of the cosmos is no longer speculation alone. It is something that can be approached through observation and mathematics. Yet the philosophical implications remain. If the universe had no beginning, then creation, in the traditional sense, becomes unnecessary. If it has no end, then death, entropy, and collapse do not mark a final conclusion. They are just phases in a larger, perhaps infinite, process. Life itself, human thought, and the flicker of civilizations are set against an immense backdrop of duration and scale. Consider infinity for a moment. Numbers can stretch endlessly, but human experience cannot. Time can be conceived as eternal, yet our bodies, thoughts, and consciousness are temporary. In a universe without beginning or end, our lives are minuscule, a single blink in a vast, silent expanse. And yet, knowing this, there is both humility and freedom. Our smallness does not diminish significance. It highlights the preciousness of the brief moments we inhabit. Philosophers have long debated whether eternity is something to be feared or embraced. Augustine, for instance, struggled with the notion of time itself, imagining that before creation there was no before because time was a property of the universe. Modern cosmology touches on similar dilemmas. If the universe truly has no beginning, what does that imply about time, causality, and the flow of events. Concepts that seem obvious in daily life, cause and effect, before and after, begin to blur at cosmic scales. There is also the paradoxical nature of human curiosity. We are finite beings, yet we can contemplate infinity. We are temporary observers, yet we track galaxies moving billions of light years away, remember light emitted billions of years ago, and predict motion trillions of years into the future. A universe without beginning or end is not just a scientific fact. It is a mirror reflecting the paradoxes of consciousness itself. Your mind, lying in comfort, participates in this vast, ongoing inquiry. Many find this perspective calming. A universe without beginning or end is patient, stable, and predictable in its own way. It does not rush. It does not demand immediate answers. Its processes unfold according to laws that persist beyond human lifetimes. Yet others may find it unsettling. The scale is so vast, the duration so immense, that everyday concerns, achievements, and failures can feel fleeting, almost insignificant. And perhaps that is precisely the point. To recognize the immensity of time and space is to gain a sense of perspective. Throughout history, humans have used stories, myths, and philosophy to grapple with eternity. Cycles, reincarnation, endless heavens. These narratives are cultural attempts to reconcile the finite and the infinite. Science now offers a complementary perspective. Through observation, mathematics, and logic, we approach the same questions, finding evidence and patterns where our ancestors speculated. And yet, even science encounters limits. Multiverses, dark energy, cosmic inflation. They hint at realities so vast and strange that human intuition struggles to grasp them. For you listening now, there is a gentle paradox. The universe may be without beginning or end, yet you exist within it, aware, curious, engaged. Your experience is fleeting, but your attention connects to the larger rhythms of the cosmos. You may never observe another universe, witness the birth of a star from hydrogen and helium, or see the end of galaxies drifting apart. And yet your mind can trace these processes, imagine them, and reflect on them with clarity. In this, you participate in something almost eternal, the human endeavor to understand, and perhaps there is subtle solace in the ordinary, boring details. Even in a cosmos without beginning or end, the principles of physics persist. Particles behave reliably. Light travels at a constant speed. Energy transforms but is conserved. The universe, vast and mysterious, is also comprehensible, at least in part. And this comprehension is a quiet triumph of human thought, patience, and curiosity. The philosophical implications reach further. If time is endless, if space is vast beyond imagining, how should life be approached? How should knowledge, morality, and action be understood? Perhaps significance arises not from duration but from attention, the careful observation, thought, and experience that occur in the brief span of conscious existence. Even if the universe stretches infinitely in every direction, your engagement with it creates meaning, however fleeting. And so, even as sleep draws near, the mind can wander through these immense questions. Infinity is vast, time is deep, and existence is fleeting. To contemplate a universe without beginning or end is not only to explore the cosmos, it is to explore the boundaries of thought, consciousness, and the delicate tension between the finite and the infinite. Finally, consider this quietly. The universe, whether cyclic, infinite, or multiversal, continues beyond your observation. It expands, contracts, pulses, and persists in ways you cannot fully perceive. Yet you, a temporary observer, can think about it, feel it, and let it stir awe, curiosity, and reflection. The absence of beginning or end is not a limitation. It is an invitation to consider your place in the cosmos, to marvel at its scale, and to drift toward understanding, however partial or fleeting. As you lie quietly, perhaps under a soft blanket, it is natural to think of time as a simple, steady flow, past behind you, future ahead, the present moving forward like a river. Yet in the cosmos, especially in a universe without beginning or end, time is far stranger, far more subtle than our daily experience suggests. Modern physics, beginning with Einstein in the early 20th century, revealed that time is not an absolute river flowing uniformly for all observers. Time is intertwined with space, forming a four-dimensional fabric called space-time. The speed at which you move, the presence of massive objects, even gravity itself can stretch or compress time. A clock near a massive star ticks slightly differently than one far away. The passage of moments is not universal, it is local, relative, and malleable. Consider the Earth as you know it. You move, spin, orbit the sun. A clock on a satellite above Earth ticks fractionally faster than a clock on the surface. These differences are tiny, often imperceptible in daily life, yet they are real. They are reminders that time, which feels uniform and simple in your bedroom, bends under the weight of cosmic reality. Now expand this thought to the scale of the universe. If the cosmos has no beginning or end, then time itself might be infinite in both directions. The past may stretch endlessly, the future may stretch endlessly, and our familiar notions of before and after may become subtle approximations. What we consider the birth of the universe, the Big Bang, might be just a local event in an ongoing, perhaps eternal temporal fabric. Quantum mechanics adds another layer of strangeness. At the tiniest scales, time becomes probabilistic, uncertain. Particles can appear and disappear, interactions occur with probabilities rather than certainties, and causality, the usual sequence of cause and effect, becomes less rigid. In such a universe, beginnings and ends are not as absolute as they seem in everyday experience. Time, space, and events exist in a delicate, interconnected web. Imagine lying back and letting your mind drift into this framework. Time is not a rigid line stretching from a singular origin to a far-off conclusion. It is a landscape, perhaps with valleys, plateaus, and loops, influenced by gravity, energy, and space itself. A universe without beginning or end may simply be a universe where time extends infinitely, folding and stretching in ways our minds can only partially comprehend. Cosmologists sometimes speak of time as emergent. That is, time may not exist as a fundamental property of the universe, but rather as a measure of change. If the universe were perfectly static, time would have no meaning. Only with movement, expansion, energy transfer, and evolution does the flow of moments become perceptible. In a cosmos that stretches endlessly, time is less a container and more a record of events, a narrative woven from change itself. This perspective has profound implications. If time is emergent and relative, then the idea of an absolute beginning or an absolute end may be less relevant. The universe could exist eternally, in cycles, or as a multiverse, with time taking different forms in different regions. Your familiar clock, counting seconds, minutes, and hours, is a tiny, localized perception of a deeper, more flexible temporal reality. Philosophers have long pondered similar ideas. Augustine of Hippo, writing in the 4th century, argued that time is a property of the mind as much as of the cosmos. Modern physics echoes this subtly. The flow of moments may be both real and observer-dependent. In a universe without beginning or end, this duality becomes central. Time is both endless and intimately connected to local events, like your thoughts drifting under a dim lamp, fleeting yet anchored in a larger, incomprehensible expanse. And then there is entropy, the measure of disorder. Entropy gives direction to time. The universe evolves from less probable states to more probable ones, from order to disorder. This is why you can remember the past but not the future, why ice melts but does not spontaneously reassemble, why your room can accumulate clutter but cannot instantly tidy itself. Even in a universe without beginning or end, Entropy ensures a kind of temporal arrow, guiding processes forward, creating a subtle flow even in an infinite continuum. Yet the arrow of time does not resolve all mysteries. In some cyclic universe models, entropy might reset during each contraction, creating new expansions with fresh arrows of time. In multiverse scenarios, each universe may have a different temporal rhythm. Time is no longer a single, uniform dimension but a vast and varied landscape, unfolding differently depending on context, energy, and cosmic history. For you listening, this can be comforting or disorienting. On the one hand, time is not rigid, frightening, or absolute. It is a flexible framework shaped by physical law, energy, and change. On the other hand, your familiar notions of cause, effect, beginning, and end are fragile when applied to the cosmos. The flow of moments in your room tonight is real and meaningful, yet only a small slice of a far larger temporal tapestry. And yet, for all its strangeness, time remains intimately connected to experience. Your heartbeat, breath, and thoughts are anchored in the flow of seconds. Your memories, plans, and observations are all embedded in this continuum. Even if the universe stretches infinitely in both directions, the present moment remains a tangible, immediate point of contact with reality. Time, in this sense, is both vast and intimate. Finally, consider this quietly. In a universe without beginning or end, time itself may be infinite, malleable, and emergent. Yet within this infinity, your consciousness perceives, reflects, and experiences. The universe, sprawling beyond comprehension, still touches you through your awareness, curiosity, and reflection. Even the most boring details, the slow drift of galaxies, the ticking of a clock, the faint afterglow of the Big Bang, connect you to a vast, ongoing temporal rhythm, both endless and intimately yours. As you lie back, comfortably cocooned in your room, it is natural to feel a sense of awe, tinged with quiet humility. The universe stretches far beyond what you can see, measure, or even imagine. It is vast, ancient, and governed by principles that operate whether you observe them or not. And yet, tonight, through this journey, you have glimpsed fragments of it, traces of its profound nature, and hints of mysteries that defy complete understanding. We began by imagining the very first moments of the cosmos, the searing heat, the formation of hydrogen and helium, and the afterglow that still permeates the universe today. Those first seconds and minutes, dull in their numerical ratios yet immense in consequence, laid the foundation for stars, galaxies, and everything you know. From such seemingly mundane beginnings, the entire cosmos unfolded, obeying laws both precise and subtle. Then we explored the unseen scaffolding of reality, dark matter and dark energy, which constitute most of the universe. The stars, planets, and galaxies you can see are just a fraction of the full story. The majority of existence operates invisibly, quietly shaping cosmic evolution. It is a reminder that what is most significant is often hidden from view, that the universe's deepest truths reside in the subtle, the dull, the almost imperceptible. From there, we considered the ultimate fates of the cosmos: heat death, endless expansion, or a collapse and rebound. Each scenario highlights the impermanence of structures, the fleeting nature of stars and galaxies, and the vast scale of cosmic time. Even in a universe without an apparent end, processes unfold in quiet, patient ways, guided by laws that have persisted for billions of years. Your own life, like every other, is just a small part of this immense narrative, yet its significance lies precisely in its temporary clarity and awareness. Next, we contemplated cycles and rhythms, the possibility that beginnings and ends are relative, that the universe may expand, contract, and expand again. In such a framework, eternity is not linear but circular, and your awareness is a brief pulse in an endless cosmic heartbeat. Science and philosophy intersect here, suggesting that the universe may not have a singular origin or a final conclusion, but exists as part of a continual process that transcends ordinary human perception. The multiverse added another layer of wonder. Your universe may be only one bubble among countless others, each governed by its own laws and unfolding according to its own timeline. Every possibility, no matter how improbable, might exist somewhere. In that vast expanse of reality, the concepts of beginning and end blur, and infinity becomes not just temporal, but structural, stretching across countless cosmic landscapes, invisible yet real. Time itself, we discovered, is more flexible than we experience in our daily lives. It is intertwined with space, shaped by gravity, energy, and motion. In a universe without beginning or end, time may stretch infinitely, fold upon itself, or emerge from change itself. The flow of moments in your room tonight is both intimate and fleeting, yet it connects to a grand cosmic rhythm extending far beyond comprehension. All of this beginning, end, cycles, multiverses, dark matter, and the nature of time challenges our ordinary understanding. Yet it also highlights something profound. The universe, in all its vastness and strangeness, is intelligible to human thought. Your mind, even in quiet reflection, participates in its story. You are, in your own way, an observer of eternity, a witness to processes that span trillions upon trillions of years, across distances that defy imagination. There is a subtle beauty in the quiet, almost boring details. The ratios of protons to neutrons, the faint hiss of cosmic microwave background radiation, the precise measurements of galaxy rotation. They may seem trivial at first glance, yet they reveal the structure, stability, and elegance of reality. The mundane, in this sense, becomes extraordinary. The universe's secrets are often encoded in details so small, so subtle, that only patience and attention can uncover them. As you drift closer to sleep, you can imagine the universe as a vast, ongoing narrative, without a definitive start or finish. Stars rise and die, galaxies drift, universes may bloom and fade, and yet the underlying principles, the laws, the forces, the cycles, persist. The cosmos is patient, unhurried, and constant in its complexity. It has no beginning or end in a human sense, yet within it, patterns emerge, structure arises, and life, consciousness, and curiosity can flourish, even if only temporarily. And here is the most subtle reflection of all. The universe may be without beginning or end, yet your attention, your awareness, and your curiosity grant it meaning. The cosmos is vast, and your existence is fleeting, but by observing, thinking, and wondering, you connect directly to the rhythms of infinity. Each question you ponder, each insight you gain, becomes a thread linking your consciousness to a tapestry that spans time, space, and perhaps countless realities beyond imagination. The universe without beginning or end is a paradox, an invitation, and a mirror. It invites curiosity, rewards reflection, and humbles the imagination. It is a mirror because in trying to understand it, we glimpse the limits and potentials of human thought itself. You are temporary, finite, yet capable of contemplating infinity. You exist within impermanence, yet your mind can perceive patterns that transcend it. Finally, consider this quietly as sleep draws nearer. The universe stretches beyond comprehension, yet its essence touches you. Invisible forces govern galaxies. Cosmic cycles may repeat endlessly. Time may fold and emerge. Countless universes may exist beyond observation. And still, your consciousness is aware, curious, and engaged. In this awareness lies a quiet form of eternity, a bridge between the finite and the infinite. So, as your breathing slows and your mind drifts, you can rest in the knowledge that the universe, with all its complexity, strangeness, and subtlety, continues beyond your observation. And yet, in your reflection, you participate in its story. The universe without beginning or end is vast, mysterious, and eternal. But tonight, in this quiet moment, it is also intimately present with you.